So this class is going to have two parts, okay? One is that we finish the examples, economic examples we understand, and you ask me questions about the programs. And then the second part is we all leave, and then we reconnect one by one. Jameson, you're already set, so I read your proposal, so you're more than okay to go. So after we finish the first part, Kevin, also I know what you are doing, so you are free to go after we finish. So you're okay. And I need to stay with Jack and Ryan to see what are your plans and ideas. Okay.
Professor, I thought
Yes.
we were meeting one-on-one after all the rest of them, just so I can show you one.
Oh yeah. If you want to show me something, yes. But what we do is once we finish the first part, we leave, and then we say who's first, and then each 10 minutes you can connect. Okay. Makes sense?
Professor, I volunteered to go last.
Okay, perfect. Okay, who's gonna Jameson? So you need to do anything else. I read what you were proposing, and I'm happy with that. Okay. So who
Sounds good.
Perfect. So who wants to be first, Ryan or Jack? After we
I
finish.
can go first. It's cool.
Okay, so Jack, Ryan, then you, and then Kevin. Okay. So as soon as we finish, I give you the times. Okay, guys, can we please go and read? Let's remember it's reading and understanding before going to program. That's what I'm trying to tell you. Let's go to this part here. So let's read 3.3. Let's understand what we're doing. Okay, let's say 5 to 8 minutes to read, understand. And once we understand that, please open the Excel, the MATLAB file that is called, where is this one here? Yeah, it's called exercise 3_3_3 chan, alpha chan. You have that, I send you this M file. Okay, first, please guys, invest 5 to 10 minutes reading. Okay, you need to understand what you're doing. And once you understand what you're doing, the program is going to be a piece of cake. Got it? Okay, guys, so you read while I bring some water to my place. So it's just 2 pages. Three more minutes, guys, of reading, then we start solving the mathematics, the program. Okay, one more minute, guys, and we solve it. Okay. So this is a, do you see my MATLAB?
No, we still see the book,
Yeah,
the PDF.
Yeah. So let's go to MATLAB. Here we go. Now, you see this? Yep. Okay, great. So this, you have this file, guys, is exercise 3.3 Chan. No, and the basic idea, guys, this is a demand supply equality. So you know what? If we know that the market is a kind of a temporary equilibrium, it's because it's a dynamic equilibrium. So QD equal QS. If we define QD as 4 minus P squared, remember that QD is always, well, must be a negative slope, and QS is a positive slope. Okay, so that's what we always see. One way of solving this system, guys, is you simply say, okay, QD is 4 minus P squared equals QS 4 minus P. And then what you end up having is a quadratic function. Do you agree? And then if you have quadratic function, what you're trying to do here is what is a price that clears the market? That's all the idea of in this point here. What is a price that basically that clears the market, meaning that the quantity demanded equals a quantity supplied. Okay, we're going to do this with two methods, and you're going to do a third method today in class. Okay, the one is the F0s, remember? So we can find where this function crosses zero. This is this one. Or we can find the roots. We know that the polynomial roots of a quadratic function is very simple to obtain. Okay, so I'm saying here method one. So if I change this to method two, it's going to do method two. but I will start with method one. What I'm doing is I'm first plotting f. So what is f at f? So what I've done is I have defined the functions down. I have defined three functions. Function y, f of p, this is the function. I need to enter p. I have created another qp, so this is the demand function. Okay, and I've created a qs, that is the supply function. Three functions in between the function. Okay, so let's do this by steps. So let's take a look to what happens here. You don't see my screen. Wait a second. Do you see the result? So remember, f plot works with functions. So it's plotting p squared plus 4p minus 5. And then you see that this is like parabola like that, right? Now, if I do method one, so the computer is going to ask, is method one? Yes, I'm selecting method one. So what I will do is, it will simply, I'm drawing a couple of things. What it's doing, guys, is finding the 0 in -6 and 3. So where this function crosses 0 in -6 and 3. So if you see the graph, it crosses 0 in the value -5. You see here, -5 goes to 0. So this is the first 0. What is the second 0? The second 0 happens between 0 and 1, happens at the value 1. You can see that. Now, what is interesting, guys, is my optimal, as soon as this is my quantity, right? This is my price, sorry. I cannot have a negative number. So obviously what I'm doing is this optimal -5 doesn't work. The one that should work is optimal 2. So what I'm doing here is simply I'm saying, if the optimal one is larger than 0, this is going to be my optimal. If otherwise, my optimal is going to be optimal 2. All right? So let me stop here. And what is your optimal? Your optimal is 1. Okay, if you see the graph, indeed, this function crosses 0 at 1. Okay, make sense? Now, what do we do? I'm with method 1. So I can simply start doing this. So I compute what is my price optimal, and then I compute what is my quantity at this price, the quantity demanded at this price, and what is my quantity sold at this price. We can do that. 3 and 3, of course, because QS should be equal to QD. So at price 1, the market is going to clear. How much is going to be how many products we're going to produce? 3. Make sense to everyone, guys? Guys, make sense?
Yeah, it makes sense.
Okay, perfect. So this is one method. When you equal QD, QS, and then you find one single equation, quadratic equation, then you find the solution, quadratic or linear. And the other way of solving this one, guys, is solving equation by equation. You know, what I'm doing here is I'm plotting G is this one here, is my demand, and H is my supply. So if I draw, let's do this up to here. Here we go. So my demand, remember, is we just focus on the positive side of the equation. Negative doesn't work. So if you just focus from 0 to the right, so this is my demand function, QD, and this is my supply function. And what I want to find is this point here. You see the intersection point. That's what I'm trying to find. And as you can see here, guys, the intersection point is going to be at 1 and 3. It's exactly the same as the previous result, correct? So what I'm doing here is something very rudimentary. I'm defining the functions, the polynomials. This is the polynomial for QS, right? If you remember, QS is this one. It's 4 times x or p minus 1, and the other one is a quadratic. So I need to add this 0 because this one here is a quadratic. Remember, it's minus p squared, so that's why it's minus 1. It doesn't have p, 0, and it has 4. Do you understand this notation here, guys? This is the polynomial way that we write in MATLAB. Make sense to you?
Yeah.
Perfect. So if you do that, well, this is my question. I need to find the roots of what? Of the difference, QS minus QD. So I need to subtract these two. I have my equation, then I find the roots, correct? And then from the roots immediately, what I'm doing is I'm selecting the one that is larger than 0. Immediately, instead of doing my if condition, remember, the other way of doing this is simply add an if condition, if else condition, like this, or I simply do this. Take a look to this trick. This means if the roots of q minus s minus 1, so let's take a look at this one here. So what this is producing. You see 0 and 1. Do you see that? If you multiply 0 and 1 so that the roots, take a look to what the roots happen. What are the roots? Minus 5 and 1. So if I multiply this by 0 and 1, what is the one that is going to survive? 1. Agree? So, and that's exactly what this is going to be doing. So P opts is going to be 0 or 1. Okay, so 1 is the one that we select. And then what I do here is simply I select, you know what, P opts, find P opts not equal to 0. Of course, guys, this is completely inefficient. Just wanted to show you, remember the use of find. How do you do that? You need to show me that in your work, okay? Even though it's a kind of a, come on, I can do this directly. No, better if you show me that you use how to find values in an array. And here we go. The P optimal is 1, and then I need to simply compute. I need to compute my optimal quantities, and I will stop here. You know, QS optimal 3, QS optimal 3. Sorry, the supply and demand 3, and that's it. You agree? Okay, so this is method number 1. So let me quit debugging. What about method 2? So method 2 is going to be around here. Okay, so if I want to run method 2, I simply I change this by method 2, save it, and run. So take a look now. It will ask, is method equal 1? No. Okay, is method equal 2? Yes. And then here what I'm doing, guys, is I'm entering manually. Okay, this is my square, this one here. Okay, so manually I'm doing the polynomial. I'm finding the roots, and then I'm finding the roots that are not equal. The roots that are larger than 0 that are not equal to 0. And then you find the exact results as before. If you run this one here, if you continue running this one here, yeah, the remaining part is the same. You arrive to this position. That is exactly the same answer with method 2. Okay, so now, work for you now. I want you to create a third method. Okay, so method is going to be the third method. Method 3 is using symbolics. Okay, so what you need to do now is basically say, you know what, if method equal 1, else if method equals 2, and an else condition in which you use the symbolics. Okay, you do it. 5 minutes to do that, guys. I want you to create a third method that is using symbolics. The only thing that is going to change is that you need to add an else condition here, add sims, and then you work with that. We have done examples last week. Okay, 5 minutes to do this. So now you are going to add one additional method that is going based on symbols, not symbols. Okay, 1 more minute, guys. Okay. So if we do, take a look to this, guys. Remember, if you want to work with symbolics, okay, first of all, you need to define the symbol. So I want P to be a symbolic. So I create my symbolic. So let me move this. So let's do this step by step. So now I'm creating method 3. You need to create first, you need to modify first this one here. It's going to be else if, because you have now 3 methods. So it's not method 1, it's not method 2. It's going to go to here. So let me save this one here. Let's run. When you want to work with symbols, guys, you need to first define the symbolic, then the function. And then remember last class, we talked about this function that is beautiful, the sim to poly. So what I will do is I will let MATLAB to create the sim. Here I created manually. But in this case, I will let MATLAB to create my polynomial using sim to poly. Take a look to P. 1, 4, minus 5 is exactly the same as this one here. And once I have this one here, I do the process as before. I compute the roots. I compute the optimal that is larger than 0. And then from the larger than 0, I select the one that is not equal to 0. And then I'm done. Do you see that, guys? So this is a way of working with symbols. And symbols really help a lot, guys. Make sense to everyone? Guys?
Yep.
Okay, perfect. So if you want to copy this for just 1 minute to copy, and then we move into the last exercise. You can run this, obviously, and you're going to obtain the same results later. You see? Exactly the same. Okay, guys? Questions? So let's do the last reading. So can you please take a look to, let me open, what's this called? Profit maximization. Yes. Okay. So let's take 10 minutes to read this one here, guys. This one is, let me show you my screen. You see my screen?
Yeah.
Yep. Okay. So 10 minutes to read these conditions of profit maximization, understand this part here. And what is important, guys, is you need to understand this graph here. What is the meaning of this graph, etc. 10 minutes to read carefully, understand carefully, and then we go into the MATLAB program that is called profit maximization. Okay. First, the reading, and then we go into the text, into the program. Okay, guys. Okay, 3 more minutes, guys, please. One minute, guys, and then we'll start. One minute. Okay, guys. So what is crucial about all this theory, guys, of profit maximization is the following. Remember this typical condition that we maximize the profit when the marginal cost equals marginal revenues. Remember that? Okay. However, are you with me, right? Jack, Kevin, Jameson, Ryan.
Yep.
This is like
Yes.
a microeconomics 101, right?
Exactly. So, and the issue with this condition is that the marginal revenue equals the marginal cost always in 2 points. Okay, so this point here and this point here. So the first order condition, that is the marginal cost equals marginal revenues, are not sufficient condition to find the minimum, because if I find this one here, this condition also satisfies marginal cost. You see the slope of the cost of the revenue versus the slope of the cost. They are exactly the same here and here. However, guys, what is interesting is that one of the points always minimizes the profits, right? And this point here is this one here is basically, you can see these two marginal cost marginal cost equals marginal revenue, but they represent a minimum. Okay, so that's the trick. We need to identify the second derivative. Okay, in the second derivative, the second derivative of the revenue must be smaller than the second derivative of the cost in order to have the maximum, because this is maximization condition. Remember, if you are in a maximum, the second derivative is negative. And that's it. And that's what we're going to try to do using MATLAB. So here we go. So we're going to do this using MATLAB. Guys?
Yeah, we see it.
Yes, perfect. So what we do is we have a symbolic, we are doing symbolic, so I define my functions. Remember that I don't need to do this sim again because it's already symbolic here. But in any case, I'm defining my revenue function like a quadratic. I'm defining my cost function as a cubic. Okay. Then I'm defining P is going to be R minus C. This is my profit function. P prime is the first derivative of P, of my profit function. And the second derivative is the second derivative of P. Okay. Then I have the marginal revenue is going to be diff of R, the first derivative of R, and the marginal cost is the first derivative of C. All right, so let's do up to here. You can see P is a cubic function. P prime is this one here. This is my, what is this? Oh yeah, this is the first derivative of my revenue, so it doesn't make anything at this point. My marginal revenue is this one here, and my marginal cost is this one here. Okay. So I want to find the values. What I will do is I will create my prime. I will transform this into a numeric. So that's why I do the symbol to polynomial P prime. And then what I do is I simply compute the roots. Take a look. No. So the roots of P prime are these ones here. 36, what's that? 36 and 3. Make sense to you? And then we do the second derivative just to be sure that, because the first derivative doesn't provide you all the answers. We do the second derivative. So I have minus 150 and I have 100.5. Got it? So obviously the first one is going to be the one that's going to provide us a maximum. Then I do, if my root is smaller than 0, okay, I simply transfer the first value here, 36.5. Otherwise, it goes to the second value, 3. Well, these are simply polynomials, are easy to understand. So you can see my P optimal, my Q optimal is going to be 36.5. And this makes sense. 36.5 is my Q optimal. Let me see. Let me show you the Q optimal. This one here is going to be 36. Okay, is that one that minimizes, that equalizes the first derivative, and the second derivative of the of the revenues is smaller than the second derivative of the costs. So this is this Q here. This is the optimal Q. Okay, then we compute what are the revenues and costs, and then we can do some plots there. Then I have my revenues. This is a polynomial. My costs are optimal. My return, my optimal return is going to be a 4.13. It's e to the 0.4, and my optimal cost is going to happen at 2.4817. Okay. Then we do, you know what this is? These are plots, guys, just to show you. You know, you need to do this stuff also in your papers. You know, you just show me F plot, easy plot, normal plots. You know how to work with this stuff. So you need to have that in your programs, please. Don't forget that. Okay, you need to show me that you know how to handle subplots. You need to show me how to handle. You know, easy plots, F plots, regular plots. If you can do some, plot three-dimensional graphs, all this stuff. It's just show me, and the thing is that you also practice, guys, with MATLAB and any other program language, guys. Is simply practice. Okay, so at the beginning it's very hard, but then you as soon as you do more and more, you're gonna feel more confident about what you're doing. And the more confident you feel, you're going to do more complex things. Got it? So I think with that, guys, if you are able to create something that is, you know, needs not to be perfect, I don't expect something perfect, but I expect something that, you know, really shows that you're, you know, I have learned something that I can do. Make sense to everyone? Questions? So what I will do also between today and tomorrow, I will send you more past programs so you can take a look to what your colleagues have done. Okay, so just 3-4 examples that are, you know, very decent examples that you can use them as a benchmark. And that's it. Make sense to everyone? Okay, so from now on, guys, we have 1 week to do your projects. So the delivery, please, needs to be Wednesday before 4. Next Wednesday before 4 p.m. Okay. Ryan, Jameson, have you heard about that? The final delivery of the assignment is next Wednesday before 4 p.m. Got it? So you have exactly 1 week, but before 4, because after that I'm going to be traveling. Make sense to everyone?
Professor, how are we gonna go about the next half an hour?
Oh, yes. Wait a second. Okay, everyone is clear? So now the next half an hour, guys, what we're going to do is the following. So Jameson, you are already done. So you are, I read what you are doing. So I'm happy with the things you are doing and really interesting stuff. So good luck with that. If you have questions, please email me and then we can start moving, okay? So what we do now is I stay with Jack. You just leave and immediately enter again and just wait in the waiting room, right? So I just stay with Jack. Please immediately enter. It will be very quick, okay? And then we talk. Okay, Kevin, we see you in a minute. Just leave and then enter again and then just stay in the waiting room.
All right, thanks for press. Have a good night.
Yes, see you guys. Take care. See you, Jameson. Take care. Okay, Jack. Let me.
Hi, Professor. How are you?
Yeah, very good, very good. So I don't need to.